What's up, guys? How y'all doing? I hope that you are having a good day or good night on whatever timeline you're in. Like always, and then you ask yourself this question: Who the heck did a math video at 5:58 a.m. Right? It's so insanely early. I mean, to all y'all Houstonian and who is in the Houston timeline, often wonder that. Well, on this occasion, I did it, and I'm pretty sure many people did that too. So yeah, stay tuned with me, okay? Today, the topic is probability, but there's a double integral I really want to cover because again, if we the best way to learn is constantly reviewing new own concept, and apply it to new concept. So yeah, I think this this problem will reveal a little bit of double integral and the way to think, the way to set up about the problem. Okay, without being safer, let's dive. So um the integral is, in class we learn how to prove that integral from 0 to infinity of p y greater than y dy equal to e of I. And this e, I think this is a mean, right? Or variant, I don't know. I have to double check. Okay, and this is, yeah. So how you gonna do that? Well, you're gonna replace this guy right here, p y greater than y. Okay, what does this equal to? It equal to, let's write the same, f of I, the function of x dx from y to infinity. Okay, and then dy. So yeah, the first step is you replace this with something familiar. In mathematics, we always, we have a complicated expression, right? We try to replace it with something familiar, something that in the past. And I wonder, like, human did it too. Like, whenever you find something odd, something strange in your life, you always like, okay, this seems like this I do before. You see what I'm saying? Okay, now this is the interesting part. We just set up a double integral right here. Okay, double integral. And how you gonna do that? We're gonna do it by the methods we're gonna do this is we're gonna do by change of integration order. Okay, so how are we gonna do that? Let's lay both the step. So the first thing you're gonna have to acknowledge is whatever inside we do first. So in this case, we do x first, and then we do y. Okay, so we the first step you have to know is you have to acknowledge the order. In this case, so inside first, dx, and then outside. Okay, always dy. Okay, once you acknowledge the order, you want to swap them, right? You want to do y first and then x instead of x first then y, like the original. What you're gonna do, you have to draw a picture. Okay, you have to draw a picture. You have to draw like this is y o x. It's y o x. And you say this is the original, and this is the change of integration order. Okay, now you have to draw the boundary of the original first. So at first look at dx. Okay, dx y is equal to y, and then yeah, you remember this. If something is fx dx, right, the boundary would be y1 y2. Okay, not x1 x2. Remember that. This is very, very important. Because you was you was dealing with the function, you know, you were dealing with the function, not the variable. Okay. Wait, actually, hold on. Let's double check. No, actually, wait 1 second. I'm sorry. I was wrong, actually. X equal to y. X1, no. This is not okay. Let me correct myself. This is x1, x2. I'm sorry. Now it makes sense. Okay. This is x equal x1, x equal x2. Okay. This is how you do the integration. So if you look at this, fx dx. Okay. So x1 equal y and x1 equal infinity. So we have two boundary, right? We have, in this case, in the original, we have x1 equal y, x2 equal infinity. So what you're gonna do is, x1 you treat it as x and x2 you treat it as x. Oh, I really don't want to confuse you guys. No, okay. So since I don't want to confuse you guys, think about this like this: x equal y and then x equal infinity. Okay, to x equal infinity. Think about it as a boundary. You can think, very important, you can think whatever way work for you. Okay, but I'm gonna do this way. I don't want to confuse you going x1 equal y and x2 equal infinity, because it make more sense. Okay, so what you're gonna do is you have to draw the line. Okay, so x equal y is like this, right? X equal y is like this. Say this is y, okay? And y is from 0 to infinity, okay? So x equal infinity is somewhere right here. Somewhere right here, right? The boundary, like very far away, okay? So the first step, you have to understand how it works. So when you do the integrate inside, you sum it up like on of the thing. So the step is like, you have this, you have this, you have this. Okay, that's x to infinity. Okay, and then y equals 0 to infinity. Oh, actually, start like this. This is the act of saying up x equal y to x equal infinity. Okay, that's the action. Okay, and then after you do that vertically, you sum it up horizontally. So this you sum it up on this, and then this act of summing up on of the line, the x line, horizontally is is defined as you taking into consideration the bond from y equals 0 to y equal infinity. Okay, I know I must be complicate you guys, complicate the hell out of you guys, but let me, confuse you guys, but let me try to explain again. So the first boundary, x equal y to x equal infinity, you define the boundary in the vertical line. So you say, okay, I call this vertical boundary. Okay, you say, okay, how far can I draw the line? How far can I draw the arrow, right? That's what it means. Okay, how far can I draw the arrow? Now, the second step, you'd go from y equals 0 to y equal infinity. It means that you sum up on the arrows. Okay. Let me write down. Let me write down like this. It makes more sense. So this means how far, how long can my arrow be? Okay, And this boundary mean summing up on of my arrow horizontally. No, not horizontally, vertically. So you notice that we do from horizontal first and then vertical in this case in the original integration. Okay, so I hope it makes sense for now. At first, okay, x equal y to x equal infinity, you want to make sure how long your arrow want to be. Okay, like okay, this x equal y and this x equal infinity. You see, okay, my arrow can be from here to here. Now, and then the second step, you do integration from 0 to infinity. 0 to infinity means the y fluctuates from 0 to infinity, means you sum it up on the arrow from y equals 0 and then to y equals infinity, and then you get the area. Okay, this area right here is your integration. Okay, now let's say you want to change integration order, right? You want to change integration order, but it means that, okay, I'm gonna go here. It means that, you know, the integration is the same, the result is the same, which means that the area is the same. But, you know, instead of, you know, doing vertical first, this should be horizontal. I'm gonna review my video from time to time, okay, and then I might publish a new video. It was so confusing. Okay, so how do you get the same area? You asking. Let's say you wanna do, okay, this is your integral, okay. So when you change the order, the function inside does not change. The boundary change. Now you see it's dy first and then dx, right? And then you have to find a boundary, okay. First you find a boundary of y, and the second thing is you find a boundary of x. So how you find a boundary of y? Well, if you look at this, your brain intuitively tell you that you can do this too. You can first, you know, you can define the arrow from here to here. You can see how long it can be, okay, and then you sum it on up this way. You sum it on up that way, right? You should get the same area under the curve, right? It's the same area right here is the same. It might not look obvious, but it's actually the same. Let me actually make it obvious by, you know, let me see. Okay, this is infinity. Imagine infinity right here, right? You summing up all that. Okay, does it look similar now? It kind of looks similar, right? Yeah, let me count this. This is area 1, this is area 2. A1 is equal to A2. Okay, so how are you gonna do that? Okay, at first you see how long you can draw the arrow vertically. So what's the boundary of y in this case? Y is from this line right here. Let me, this line right here, right? I mean y equals 0 to this line right here. Let me do it on different color. I'm gonna do it in orange to this line right here, right? I mean y is from 0 to x. You agree? That's how far our arrow can draw. X, where's x from? Very simple. X is from this point right here to this point right here, right? That's the boundary of x. So 0 to infinity. You agree with me? And then, yeah, and then that's it. That's how you define integral. That's the motivation behind integral. I'm gonna attach the video in the description link. You know, I got the, yeah, maybe if you, I confuse the hell out of you guys, you can watch all the video. So now let's evaluate it. This is very simple. You see this thing right here, this dude right here. Let me do it in there. This purple function right here, since this is not a function of y, it's a function of x, you can pull it out. You can pull it out. And you can do this first. You can do this first, right? You can do this one right here first, and then what it will equal to? It will be equal to integral of 0 to x dy is equal to y 0 x. I'm gonna put this like this dx, and then you plug it in the value. So y equal x minus 0 is x dx. Okay, then you break the bracket, because everything you can multiply wherever you want, you can love whoever you want right now. So fy x dx, and then according to my note, this is the definition of mean of y. Okay, but yeah, that's how you do it. And you know, that's I try to review I try to review it. You know, I try to review change of order. So the motivation behind change of order is, you know, you start, instead of, you know, doing horizontal first and then vertical, you do vertical and then horizontal. And you know, it's always start with like how long the arrow could be, and then you summing up on the arrow. That's the act of changing of order. That's the motivation behind double integral. And make sure your area is the same. The area, you know, is the same. So in this case, a1 a2 is the same. Okay, I hope I don't confuse you guys. I hope you guys can learn some new things today. I hope. And then, you know, thank you so much for watching my video. You know, I hope you have a good day, good night, whatever time are you in again, and I wish you a healthy and happy life. Thank you so much.